A radioactive substance decays following this given equation, and we want to find the half-life where T is measured in days. So we want to know, given a starting amount, how long does it take for that initial amount to decay to half of what we started with. So a couple of things that we can tell looking at our given function. The number in front of our exponential expression, the 100, is telling us that that is our initial amount. So for this problem, our A is equal to 100. We are interested in when we have half of what we started with. So if we started with 100, 1/2 of A, or 1/2 of 100, would be when we have 50 grams or milligrams, or however this is being measured. So what we want to do is we want to take our given function and set it equal to 50, that's the amount that we're interested in, and solve for T, the amount of time it takes to go from our initial amount of 100 to our half amount of 50. So plugging in, we'll have the equation 50 is equal to 100 e to the power of negative 0.036 t. So we have an exponential equation that we need to solve for t that's up in the exponent. I'm going to start by isolating the exponential factor in our equation, dividing both sides by 100. So 50 divided by 100 reduces to 1/2. That will always happen when we're working with these half-life problems. So I'm going to use the strategy when solving an exponential equation to introduce the inverse operation of a log. Since I have a base of e, I'm going to use the natural log. So the natural log of 1/2 is equal to the natural log of e to the negative 0.036 t power. So remember your rules for exponents inside of a log. That exponent can move out in front as a coefficient, so we'll have a negative 0.036 t times the natural log of e, and by definition the natural log of e, since that's log base e of e, is always just equal to 1. So this allows us to simplify to the natural log of 1/2 is equal to negative 0.036 t times 1, so we can just leave that as negative 0.036 t. Dividing to solve for t, we get that t is approximately 19.254. We're told that t is measured in days, so here we have found that the half-life of this particular radioactive substance is approximately, we'll call it 19.3 days. So this is telling us that if you start with 100 grams, say of this substance, it would take 19.3 days to decay to have only 50 grams. And this half-life will stay the same no matter how much you start with. If you started with 1,000 grams, it would take 19.3 days to decrease to be 500 grams. So no matter what you start with, it will take 19.3 days to have half of that amount.